Hey guys, hope that you're still doing well. We are moving on to a new chapter. And so, with that being said, we're going to hit some new notes today. But just want to remind you to check your email. Make sure you're checking the class wall. Anything I send you that's going to have important information. Sometimes I'll change things from time to time, like due dates, and things. So, make sure you're watching that. Also, I'll have some extra credit coming your way soon on the class wall. So, make sure you're looking out for that. So, with that being said, let's just move on to some notes for today. Our next chapter is going to be over volcanism, which is the study of volcanoes. And so this is going to describe all processes associated with the discharge of magma, hot fluid, and gases. And so most volcanoes, as you can see, are going to be formed, or are here, along plate boundaries. And so you can see those there. Many of which are going to form at convergent, which means comes together, divergent comes apart boundaries. We can see that here in convergent, Earth's plates are going to collide, forcing land and magma upward, usually be characterized by explosive eruptions. This is going to be part of your mountain making processes. Divergent is when Earth's plates, usually in the ocean, underwater, are going to pull apart and leave large piles of lava as it comes up and then is cooled off by the ocean and then creates what's called pillow lava. So that's going to add to the ocean floor. All right. Hot spots are a little different, and I want to look real quick. If you can see Hawaii on the map there, Hawaii all the way up, I want to say, I don't have another picture, but from here up into here is a series of hot spots. And so those are going to be unusually hot areas in Earth's mantle where the high temperature plumes of mantle material rise upward towards the surface. And so you can see an example there of that hot spot where you have that mantle material rising up. An example would be the Hawaiian Islands. The oldest Hawaiian island is no longer considered a hot spot because it's moving as plates move. And so that one used to be active, but there's no longer any active activity over here. It's considered inactive, oldest Hawaiian island. However, world's most active volcano is currently over a hotspot. Hotspots are going to provide information about plate motion because, like I said, as they move, it can tell us how those plates are shifting, the direction they'll be shifting, as we can look at how the hotspot itself is moving. Other things that form as a result of that are flood basalts. They're going to form when lava flows out of long cracks in Earth's crust called fissures. Usually a hot spot is going to be underneath one of those, and instead of coming out of a mountain or volcano, they'll have these long cracks called fissures, and then it'll just kind of flow out instead of erupting out. And so you can see that there. In north Western America, there's a good place for that. And so there's a large area there. Anatomy of a volcano. This is just showing you the different parts of a volcano. The vent is the top or the opening. It's the exit. It's where the eruption, lava, gas is all going to come out. The conduit is a tube-like structure, which is going to channel and flow that magma from that magma chamber up through the conduit and then force its way out. As more gases are added to that magma, as it squeezes through, that's going to create pressure, and then that's what gives our explosive eruptions at times. However, those that are lacking in gas, typically it's forced up and then it will ooze out and go down the mountainside. We'll talk more about that when we get to the types of volcanoes. The caldera is going to be a large depression. It can be up to 100 kilometers. Doesn't have to be right at 100 kilometers. It can be less than, but it can be up to that as well. And these are depressions or bowls that were left behind from older volcanoes. Smaller form of that would be a crater. It's a bowl-shaped depression. These are usually less than a kilometer. They can be up to a kilometer, but they're usually less than, which is about half a mile. And so over time, as lava is going to flow out here, we see that solidified lava is going to make layers. And so that's what's going to increase a mountain size, that's a volcano at least. So that's the anatomy of a volcano. The different types of volcano, there's 3 different types. You have shield volcanoes, cinder cone, and composite. Shield volcanoes are going to be very broad. They're going to be short and very wide. They're going to have gently sloping sides and a almost near circular base. They form from lava accumulation of non-explosive volcanoes. And so as that lava comes up and spills over, as it cools off, it adds layers to the shield volcano, and that's what makes one. The cinder cone is going to be very steep. It's going to be short, or it's going to be very thin and tall. And so when eruptions eject small pieces of lava called tephra into the air, it's going to pile up down around that vent, and then it'll go up from there. But it's the smallest type of volcano. It's also going to be one of the most explosive volcanoes in terms of eruptions. The composite volcano is going to be a combo of chunks of lava from violent eruptions with a layer of oozing lava. So it's almost it's in between the shield and the cinder. It's tall, but it's not wider than it's tall. It's not taller than it's wide. It's just kind of proportionate. It's going to be cone-shaped with concave slopes. And those are the 3 volcanoes. The next thing we'll look at is making magma, or how that lava down below gets made. And so depending on the composition of most rocks, they begin to melt at temperatures between 800 and 1200 degrees Celsius. That can also change as you go down deeper because pressure increases with depth as you add more and more rocks on top of already existing rocks. The rocks, as you go down, there's more rocks on top, overlying rocks on top of the ones as you go down. And so as pressure increases, so does the temperature to melt the substances. And so ones that are more towards the surface are easier to melt. Ones as you go down are harder to melt. Another thing that can affect making magma is the presence of water, as well as other dissolved gases that affect magma formation in terms of how that happens. And so that'll also it'll also affect the way that the magma is going to leave from the mantle up through that chamber and then out of the volcano. Composition of it. The composition of magma will determine a volcano's explosivity, how it erupts in the lava flow. Like I've said before, the more gas that is in magma, it's going to increase the explosivity. And then the presence of water vapor is going to lower the melting point of materials. Like I said earlier, as we increase with depth, the pressure increases the temperature. The presence of water is going to lower that melting point. Viscosity is just going to refer to the material's resistance to flow, so how thick or thin it is, and that is determined by the temperature and the silica content of the magma, whether or not all of that stuff was really melted down or if there's still some chunks to it. All right, the types of magma, 3 types. There's 3 types of volcanoes and there's 3 types of magma. The first one would be basaltic magma. So this is going to come from rocks in the upper mantle. It contains less than 50% silica, so there's not a lot in there. And it's going to be producing low viscosity, which is characterized by quiet eruptions. It's just going to kind of bubble up and then ooze out and then down the sides of the volcano. Andesitic, it's going to be 50 to 60% silica. It's found along those ocean, continental subduction zones where those plates are. It'll have intermediate viscosity, so it's not thin, it's not thick, it's just kind of in the middle. And then that will cause it to have intermediate explosivity, so it won't be like a crazy eruption, but it won't be quiet either. The last type would be rhyolitic magma. It's going to have a high viscosity with large volumes of trapped gas, which is going to make this very explosive. and it's also going to have more than 60% silica. So you can see the more silica, the more gas, the more materials it has to blow out and erupt, and the more violent it'll be. This forms as molten material mixes with overlying crust, which is rich in that silica and water, and this is going to be highly explosive. And so just to show you the difference, basaltic would be more pyroclastic, rhyolitic would be more explosive. To show you the difference between those, I do have an example of an explosive eruption and a pyroclastic flow where there is lava coming out. You just don't see it. It's underneath the smoke there, but it is accompanied by a lot of smoke. And then also an experiment that we did last year where we did some Mentos and Coke, which is really Sprite, and then some vinegar and baking soda, and then the differences between those. If you want to try those at home, we tried it in our actual fake made volcano, but it didn't work, so I had to use another bottle for a second trial. It did work at that point. Our other one did work the first time. All that's in there is a beaker. You can use a glass jar or something. Put some vinegar, not a whole lot, maybe a quarter of the cup, and then dumps a little bit of baking soda in there, and then you'll see that it'll bubble up over. All right, so explosive eruptions, when lava is too viscous to flow freely from the vents, when there's too much pressure, too much viscosity, it's going to build up until finally that pressure explodes out, throwing lava and rock into the air. Like I said before, the erupted material, the stuff that gets blasted out, that's going to be called tephra. With pyroclastic flows, violent eruptions, when I say violent, it's not going to be throwing materials, but it'll send out clouds of ash and other tephra down a slope at about 50 miles an hour, which you don't want to be on the side of this while it happens, because it might not be anything. 50 miles an hour isn't super fast, but it's faster than most people can get down a mountain, so you want to be weary of going near active volcanoes. Lava spills out over rapidly, carrying hot, suffocating gases with it. And so there is lava underneath those hot, suffocating gases. And then lastly, what I want to talk about is plutons. And these are basically going to be areas, rock areas that can be filled beneath or in the crust. And so they are intrusive, igneous rock bodies, and they can be filled with magma. They're classified according to their size and shape. The batholith is down here at the bottom. It's the largest, and then your sills and dikes are going to be the smallest of those rock bodies. These things form as a result of mountain building processes, and so as you have plates that converge or oceanic plates that diverge, that's going to cause a shift. And then from that, especially with the convergence, as it lifts up, you'll have rock layers that go underneath another set of layers in the crust. And so that's going to help form these bodies. Same thing with ocean plate divergence. As those split, lava comes up, forms new rock layer, and then you can have water that can flow down and create areas of which magma can enter into. And so those aren't super important to us really studying it, but just know that magma doesn't just exist in magma chambers that comes out of volcanoes. There are other areas that it can fill in Earth's crust that are beneath. Not that you'll ever dig down that far with your shovel, but hopefully you won't find one. But I mean, there is some, or if you were doing some drilling deep into the crust, you might find some, but probably not. So that is all I have for you. Make sure that you are doing your assignments. Make sure you're getting them in on time, checking the wall, and doing those things. So I wanted to keep this one a little bit shorter for you. Make sure you look over this. Do the Quizlet. Look out for the quiz coming out your direction probably by Wednesday. I think it is by Wednesday. And I hope that you are having a great day. Bye.